Recording. Okay, so basically, we just want to take the steps that we were doing yesterday to pull the problems apart and do them backwards. So it's just like when you're, using PEMDAS to evaluate an expression, then you're using SADMEP to solve an expression. You do everything backwards. It's not about doing the opposite. That's part of it, but it's also doing it in the opposite order. So yesterday I was talking to you guys about look for steps 4 and 5 first, or properties 4 and 5 first. Pull it apart with the addition and subtraction first, then go back and look for 1, 2, and 6 to do after that. We won't have to worry about looking at properties 1 or 2 today at all. So it's more about looking for like property 6, and then looking, how can we then use property 4 and 5? Okay, and so property 6 was the exponent one, right? If there's an exponent on the logarithm, you can bring it out to the front of the logarithm and rewrite it as multiplication, okay, some sort of coefficient. Okay, and the WebAssign problems, when they ask you guys to do this, they ask in a slightly different way. It says write it each as a single logarithm with leading coefficient of 1. So it makes a big deal of saying that. You guys really shouldn't have to worry about that, because that's part of the process anyways, is to get those coefficients back to where they're supposed to be. So right now the leading coefficient of this is 3. We want that to be a 1. That needs to be done anyways. It's not like you have to do some special step in order to make that a 1. You're supposed to do it anyways. It's part of the process. So so the first thing I want to do is go ahead and look for those coefficients, right? Where did they go, right? So this 3 is going to go back onto the x that it came from, right? And then this 1/2 is going to go back onto the x plus 1. Or rewrite that. I have this yellow here. So that would be log of x cubed plus log of x plus 1 to the 1/2 power. So yesterday I made note that it doesn't really matter, like on log of x cubed, it doesn't really matter where that cubed is. If you want to put it here, you can, because x is just one thing. And either way, if you have it here or if you have it on the outside of the parentheses, it's still just on the x. Now, because x plus 1 is a more complex argument, I can't just put the 1/2 kind of wherever. The 1/2 can't go inside of the argument here. It has to be on the outside, because that way it's applying to everything the right way. And I can't just drop it in and put it on both things either. That doesn't work. Okay? So it is required that the 1/2 be here. So if we just kind of go straight rule of thumb, always move those coefficients to the outside, it'll be easier, just kind of remember, knowing that versus like, oh, sometimes I could do this and sometimes I have to do this other thing. You just always put them there. But on those simple ones, it actually doesn't really matter. So we still have multiple logarithms. We want a single logarithm. And so the next thing we want to think about is, how do I push those back together so I just have one big logarithm, right? The other thing I want to just pay attention to is that this is just log, right? Log, like this part isn't changing, right? And so when I'm done, I should just end up with a log. But we know that's log base 10. It just doesn't say that. Okay, but that part's stayed consistent the whole time. I'm just trying to find a way to push it together. Well, where did addition come from, right? Well, addition came from multiplication. So I need to take those two arguments and I need to multiply them together to get them to combine. So that first argument being x cubed. Oh, whoops, before I can do that, actually, sorry. We need to deal with this. What does this mean? What does x plus 1 to the 1/2 power mean? Something we talked about yesterday. What's a 1/2 power mean? Yep, right, Katie, square root. Okay, so this is really log of x cubed plus log of the square root of x plus 1. Okay. And then we go and push that together. The addition becomes multiplication of x cubed times square root of x plus 1. So that would be probably the best way to write that. So having that dot there to one, indicate that they are multiplying. Two, the dot gives us kind of space, because it's also the same thing as this. This is how I would type it. You know, you guys are going to be typing this into WebAssign. So I would type it like this into WebAssign. The problem with writing, ooh, that's fun. Yeah, my iPad cord's been a little janky today. Problem with writing it like that is that if you get a little loose with your 3 there, that 3 starts floating off, can start to drift and, you know, head over towards that index spot. Look like that maybe you're looking at a cube root, right? So if you got your sloppy handwriting going on, you could look at the wrong thing. So, but if I was going to type that into WebAssign, I wouldn't put a dot there. I would just write x cubed then square root of x plus 1, and be good with that. But the dot's good visually for handwriting. But those things are just multiplying each other. Okay. Let's try it again. And then I'll add another one here onto this for you guys. This really is one of those things that it turns out to be pretty simple, but you just really got to get a feel for it. Like once you do a couple of them, they just start to click, and then it's like, oh yeah, this is actually really simple. So, this is the first time most of you guys have done stuff like this, so it's going to be kind of weird, but it's actually pretty easy. So first thing I would notice as I look at this, these are all, both log base 5. So when I'm done, I'm going to end up with some, just larger log base 5 of something. Like I need to be done, it's all going to be squished into one log base 5 of something, okay? So just end goal, like where am I headed, okay? Want to look for those coefficients first to see if I can move anything back to an exponent. So the coefficient here is 1, so I don't need to worry about that. Coefficient here is 1, so I don't need to worry about that. So property 6, don't need to worry about it. So now I'm looking at property 4 or 5. So I should notice that this is a subtraction. Subtraction comes from, division. So the first one should be the numerator, the second one should be the denominator. So this one's actually pretty simple. Log base 5 of some fraction. First one's the numerator. Second one's the denominator. You guys should recognize that x squared minus 4. You should recognize that for what that is. That's x, minus 2 times x plus 2, difference of squares, over x minus 2. Those are going to cancel. Okay. So we simplify this, we get log base 5 of x plus 2. You guys won't really have to worry about doing stuff like this when we solve. I think this is even more complex than the homework questions you guys have. But it is something that's doable. Like, it's just that idea that we're creating a fraction. We should always look to see if our fraction is reducible when we create a fraction. So that's all this is saying. I don't think you guys have anything like this to do. I know you don't have anything like that to do on the homework, and it's not something that I would test you guys on. So the problem that I would be more likely to give you guys, this is one that I made up the other day. This is more like what your homework's like. Log base 3 of 5 minus log base 3 of A minus 2 times log base 3 of B. So this is more like what your homework's like. So again, the first thing I want to notice is just that they're all log base 3. And if they weren't all log base 3, we wouldn't be able to do anything. And we wouldn't look at problems like that anyways, but they have to be the same in order to push them together, which should make sense. It's kind of like combining like terms. Okay? So in the end, I'm going to end up with some, log base 3 statement, one statement with all that stuff pushed into it. Okay, that's where I'm headed. Okay? First thing I want to notice, though, is look for any coefficients. I've got a 1, I've got a 1, and I've got a 2. So I need to deal with that 2. Because the B is just a B, that 2 can go inside the parentheses or it can go on the outside. Again, I said earlier, rule of thumb, just put it on the outside. I really prefer, if I can, to put it on the inside because that's where it's going to end up anyways. So I just like to do that. And again, you guys won't really see ones that have those complex x plus 1 stuff with what we're up to. So I'm not going to change much here. Log base 3 of 5, log base 3 of A, minus log base 3 of B squared. Now we did a problem like this yesterday when we were tearing it apart. What I'm recognizing is that we have these 2 minus signs here. When we looked at, I think it was the second example yesterday, right? We ended up with 2 minus signs in our answer, right? Well, why did we end up with 2 minus signs in our answer? Well, let's follow the arrow back. Oh, because they were both dividing, that made them both subtract. Well, if they're both subtracting, it must be because they're both dividing, right? So where did that A and that B come from? Well, where did that A and that, right? From the denominator. So if they're both subtracting, then they should both have come from the denominator. Or for us, since they're both subtracting, they should both end up in the denominator. And then whatever started the problem that was positive ends up in the numerator. Okay? So this log base 3 of 5, that's the numerator right here, my 5. And then these guys here are in the denominator. So log base 3 of 5 over A B squared. So since they're both subtracting, they both end up in the denominator. Anything with the condensing you guys want to talk about? Again, as far as skills you need to be walking away with for, this really is going to be the more useful one as we head forward, as we go towards solving. The condensing is going to be more important than the expanding. All right, last thing, change of base. This is a really useful little skill. It's going to allow us to evaluate the logs that we have not been allow us to evaluate the logs that we have not been able to evaluate so far. So, what I mean by that is that we've been doing problems, think about the quiz you guys took. I asked you guys specifically 3 questions, like, what does this log mean? What's the answer if you can tell me, right? What's this log mean? What's the answer if you can tell me? One of those specifically was one that you guys should not have been able to tell me. The caveat there was, tell me easily. But if I say, hey, what's log base 5 of 25? You should be able to tell me what that's equal to. Or if I say, what's, log of 100? Like, you should be able to tell me what that's equal to. Log base 3 of 1/9. I would expect that you guys should be able to tell me what that's equal to. Okay. Log base 16 of 4. Again, you guys should be able to figure out the values of those. Because this means 5 to the what is 25. Well, 5 to the second is 25. This means 10 to the what is 100. Oh, 10 to the second is 100. 3 to the what is 1/9. Well, 3 to the -2 is 1/9. 16 to the what is 4. Well, 16 to the half power is 4. Those are all things that you guys should be able to tell me the answers to. Those are all ones that we've worked through together. Okay? But then we end up with something like log base 6 of 18. Well, what does log base 6 of 18 mean? It means 6 to the what is 18. I don't know what 6 to the what is. That does not compute. Right? It exists, but I don't know what it is. Okay, because 6 to the first is 6, 6 to the second is 36, somewhere between 1 and 2. I know that. I don't know what it is. Okay, so how do we figure it out? Right? In the same way, how do we figure out what log base 7 of 21 is? And again, I really don't like that they don't put parentheses around these. Okay. 7 to the what is 21? Got me. No, it's not 3. Okay. So what this is telling us, what the change of base property, change of base formula, whatever you want to call it, is for, it shows us is that we can rewrite any log as a ratio of other logs. All that matters is that those new logs have to have the same base. So I can rewrite log base 7 of 21 as log of 21, because that's log base 10 of 21, over log of 7, log base 10 of 7. Those two have the same base. Or I could rewrite it as the natural log of 21 over the natural log of 7. Again, those are both base E. Or we could do this, we just don't, like log base 2 of 21 over log base 2 of 7. It doesn't matter what the base of your new log is as long as they're the same. Okay? We just don't do this because we don't have a log base 2 button on our calculator. Okay? But we have a log button on our calculator and we have a natural log button on our calculator. So these are the two that we use. And it does not matter which one you use. I just use this one out of habit. Okay? But it's no different than using this one. Okay? So if log base 7 of 21 means 7 to the what equals 21, and this is how we figure it out, let's go figure it out. What is log of 21 divided by log of 7? So you should all be doing this. Okay? So for me, I need to hit my function button over here on the left side. I hit that log base 10, so there's my log button. So it's log of 21. You need to make sure you close that parenthesis on your calculator. So there should be a parenthesis after the 21. You better close that. You do not want the next part to be inside that parenthesis. So close that parenthesis, divided by log of 7. Okay? It says that's 1.564575. Okay? I know in the WebAssign, like one at a time, they asked you guys to round to the nearest third place. Other times it says round to the nearest 5. So I'm just going to go ahead and do 5 places here. So it'll be 156,458. 156,458. Okay. And it does not matter which one you do, that's what you get. 1.45, I don't know what it was. Dang it. 56458. 56458. Okay. Oops. So what is that, right? Remember what the question was. 7 to the what is 21? It's saying that 7 to this is 21. So what if we check that? What is 7 to that? If I raise 7 to that power? Well, because we rounded it, we're not going to get 21, but we're going to get something pretty darn close. So 7 to the 1.56458. Okay? So you can see how close to 21 that is. So we're able to figure out what power to raise any number to get any other number by using this change of base formula, change of base property. whatever you want to call it. So how do I do log base 6 of 18? So it's always a ratio of logs. You get to choose the base if you want to do log or if you want to do natural log. Again, my habit is to do log. The only thing you can screw up here is put the numbers in the wrong spot. So how do you not screw that up? Okay, what do? The base always goes to the bottom. How convenient. The base goes to the bottom. The base is the base. So log of 6 is going to be on the bottom, and that means log of 18 has to be on the top. Okay, so if I memorize one of them, the other one has to be the other one. Okay, I don't have to memorize them both. The base goes to the bottom, the other one's got to be the top. Okay, so if I type that in my calculator, it's going to tell me 6 to the what is 18. So log of 18 divided by log of 6. Well, come on. Sorry, I need to buy a new cord. So 1.613145. So 1.61315. 1.61315. So again, checking that. What is 6 to the 1.61315? 6 to the 1.61315. That's really stinking close to 18. Right? So we can see that it works. Okay, and it's really simple. Right? Rewrite it as a ratio of two other logs. So if I said, hey, Caleb, how do I rewrite that using change of base, Caleb? Log of 100 or log of 5. Okay, looks good to me. Or you can do natural log of 100 over natural log of 5. I'll do that one this time just to show you guys. Okay, good job, Caleb. So function natural log 100 divided by function natural log 5. So 2.86135. 2.86135. That means 5 to the 2.86135 should be really close to 100. Okay. So seeing how we can do that. Okay. Now we can evaluate those logarithms we couldn't evaluate before. On the homework, I think it's like 2 of the problems. The very first, let's see, it's problems 20 and 21. They ask you in a very weird way to do this. This is all they want you to do, but they ask you in a really strange way. They give you a log like this, and they say they want you to rewrite it as a ratio of 2 other logs with a certain base. That's kind of the way it's worded. And then it says, it gives you the log, and it says like with base E. So it would say, hey, rewrite this as a ratio of logs with base E. Well, log base E means natural log. So it would be looking for you to type this into the answer box. And then the next one says, rewrite this log with log base 10. And so it would give you a different log, but it'd be like this and say, rewrite it with base 10. And so it would be looking for you to write this. Okay? That's what it's wanting you to do, is take it from log base 5 to log base 10, or log base 5 to log base E. Okay? And then the next 3 problems want this from you. They give you a problem and they say, what's it equal to? And they want this. Well, you can't get this without doing this. Okay, so you would write that stuff down on your paper, but then this would be the answer you would type in. Okay? And TI-84s and some other calculators have a button that will do all this for you. We don't all have TI-84s, okay? And my expectation is that you guys are going to be showing me that you know how to do this on your own. Okay? But there is a way to do it in some calculators with one button. Okay? But my expectation is that you guys can use the change of base formula. Okay? And it is something that we will be needing in the future. It's not just, here's this thing, look at it, and walk away from it. We will need this later. Okay? So this condensing thing, this change of base thing, these are both skills here that we're going to need when we go into the solving realm to help us solve. So don't let those drift off. Anything feeling wonky you guys want to talk about? We just want help with the